we're going to solve exponentials using common bases. That's one way to solve exponential equations. So here are our steps. We'll talk through the steps and then we'll do some of these. So we rewrite it using a common base. So if it doesn't already have a common base, we need to make it have a common base. Then we use the properties of exponents to simplify each side. Then we use the one-to-one property. So here's what the one-to-one property says. One-to-one property says if b to the x equals b to the y, then x equals y. Hopefully that should make sense. And then we solve. Okay? And we've already pretty much gotten common bases when we were rewriting some things, so this won't be that much of a stretch from what we've been doing. All right, let's look at this first set. And we're not going to do all of these. We'll start with number 2. So our first step was supposed to get a common base. Well, we have a common base. Both bases are e. Just because it's e doesn't mean it's more complicated. So both bases are e, and then that means that the exponents have to be equal from the one-to-one property. Is that a W? So that means that I just take out the exponents. 4w minus 1 equals 5 minus 2w. And then it just becomes a super simple algebra equation. I'll add 2w to both sides. I can add 1 to both sides, so 6w equals 6, w equals 1. See how easy that is? You just have to know that taking it out of the exponent is legal, and we're good. All right? Everybody okay with that? All right, so let's jump to number 4. I have 1 over 64 equals 4 to the a squared minus 4 power. All right, so I need to get a common base because I don't have one. And let's see, could I make 4 my common base? Okay, so 4 times 4 is 16. 16 times 4 is 64, right? Okay, so that would work. If not, I'd have to knock it back down to 2. But so if I want to make this base 4, I know I just figured out that 4 cubed is 64, but what would this exponent actually be? Can I just put a 3? Because it's 1 over 64. What makes it 1 over 64? Negative. Good, so it would be a negative 3. So negative 3 equals 4 to the a squared minus 4 power. So now that I have a common base on each side, I can set the exponents equal to each other. So I get a negative 3 equals a squared minus 4. Then I can, if this is a quadratic, so I should set it equal to 0, right? So 0 equals a squared minus 1. Can you factor that? What is this? Is that factorable? We've only seen about 1 million of them, right? It's a difference of squares, so it's a plus 1 times a minus 1. That means a is equal to plus or minus 1. Let's talk about an alternate solving method here. I could have here, I'm going to move it over here since we're not doing this one. I could have added 4 to both sides and gotten 1 equals a squared. I have a feeling that might have been what you were doing. Is that why you were erasing? Okay, that's not wrong. But here's why maybe this is safer. Go ahead. What would I do here to figure out what a is? Square root, right? So when I take the square root of both sides, I don't just get that a is 1. Because I would take the square root of both sides, it would have to be plus or minus 1, and that gets forgotten a lot. All right? So there's nothing wrong with solving it that way. Sometimes it's better to be consistent. It really just kind of depends. It doesn't really matter. Either way, you get the same answer. Okay? We're all good with that one? Awesome. Okay, so let's look at number 5. Also talk about process a little bit here. Okay, so I've got 2 to the m minus 9, that is an m, right? Yeah. And then 32 to the m plus 3 power. So I would say that my common base is going to have to be 2, all right? So it'll be 2 to the m minus 9 equals, and then 32 to what power? Count on your fingers, that's what I do. 2, 4, 8, 16, 32. So this is 2 to the 5, and then I still have that m plus 3. Put that in parentheses like that. Okay? So now that I've got it down to that, I've got common bases, so I can take the exponents out and get m minus 9 equals, I'll go ahead and distribute and get 5m plus 15. You don't have to distribute in that step. I'm just skipping steps there. Subtract m from both sides, so this gives me 4m. Subtract 15, and that'll give me negative 24. So m equals what? Negative 6. Okay. Everybody good with that? Right. Let's see. I should have had you try that one. All right, we'll do number 6 together too, I guess. All right, so I have to figure out what my common base would be here. I mean, my option, clearly it's not 49, because 49 times 49, no way that's 343. With 49, my only option is 7. So 7 squared is 49, but then 49 times 7, is that 343? Here's an easy way to think about this. Here's one way to think through it anyway. 50 times 7, because that's easy to do, right? That's going to be 350, but I didn't want 50 of them. I only wanted 49 of them. You take away a 7 and you get 343. So, all right, so it is 7, and we'll go with that. So this is 7 to the 3rd power, right? And then I have that 2n minus 4 equals 7. And what do I put what exponent would that be for the 1 over 49? Negative 2, very good, times n plus 4. And if I ever write an exponent down wrong, let me know. They look like little blobs up here, and I'm doing my best to figure out what they are. So now that I got common bases, you go ahead and take them out and solve for n. I didn't think you were going to be on that long, or I wouldn't have said go right there. All right, what questions you got? Anything? We good? Sweet. All right, we're going to do the next one together too, and then I'll let you do one on your own. Okay, so here's another example of when my fraction bars disappear and go have a party somewhere else. We'll put that back in there. All right, so I could make my base 4, but I could also make it 1/4. There's nothing wrong with the base being a fraction. So if you don't want to deal with your fractions, with negative exponents, we can just make the base 1/4 here. It'd be fine to make it 4. The work would look different along the way, but the answer would be the same. So let's just make it 1/4 and see what would happen here. So we got 1/4. These parentheses are important because it's got to be for the whole fraction. That's 2. That is x squared minus 6 right there. X squared minus 6 equals, well, then if this is going to have to be 1/4, 1/4 to what power gives me 1 over 64? 4 times 4 is 16 times 4 is 64, right? And so 1/4 times 1/4 times 1/4 is just going to give me 1 over 64. So it's just to the 3rd power times 2x squared minus 5. And now that I have common bases, I can take these out. This would give me 2x squared minus 6 equals 6x squared minus 15. So, well, did I do it wrong? You have to distribute. Okay, it's okay. But thanks for trying that. Hey, at least you're paying attention. All right, so it's a quadratic. So my first instinct always is, and hopefully yours would be too, is that if it's a quadratic, I want to set it equal to 0. And then sometimes the squares just go away. That's nice too. So I'm going to subtract 2x squared from both sides and get negative 6 equals 4x squared minus 15. I guess I could have gone ahead and added the 6, but I didn't. So 0 equals 4x squared minus 9. Can I factor that? Yes, that is a difference of squares again. Right, so this gives me 2x minus 3, 2x plus 3. So my x is just going to be plus or minus 3/2. And then we're going to look at an alternate version of this as well. When I get here, instead of setting it equal to 0, I'm going to add 15 to the other side, so I get 9 equals 4x squared. And so another way you can solve this is to divide both sides by 4, and you get 9/4 equals x squared. So now you have a fraction right now, which I know you don't like, and then you have to take the square root of a fraction, which I know freaks you out, but that's another reason why I would suggest factoring all the time. But when you do take the square root of both sides here, you know it's going to be a plus or minus situation, and when you take the square root of a fraction, you just take the square root of the numerator and the square root of the denominator, and you get the exact same answer. Okay? But again, it's what you're more comfortable with and what you recognize, and when you're not going to make up math, and maybe factoring, even though I know you would never say that you love factoring, might be a better option in some situations. Okay, we good? All right, so then you do number 9. And let's see if our base could be 9. 9 times 9 is 81. 81 times 9 is way more than 243. So 9 is not your option here for your base. Good. Good. And again, I don't know if you saw me, but I had to count on my fingers for the 3 to get to the 5. Okay. All right, any questions? Let me make sure I got this. And when you got to 30 divided by 12, did part of you go, wait, that seems weird? Because it even did to me. But then I go, nope, you got to be confident and go with it. And you're good to go. Okay. All right, y'all go ahead. Y'all do number 10. Even though I'm not a huge fan, I'm sure Mrs. Archer is letting her students use calculators, so I'm going to let y'all. I don't think you really need them, but I don't want you getting things wrong because of simple multiplication stuff. You can use the calculator, it's okay. I would prefer to you like try to use your brain and then maybe use the calculators to help you, but you know, I don't want you sitting there doing basic arithmetic forever either. That's the -2. And then 3, whatever that says, I can't read it. Okay, so then that's going to become -6y minus 10y squared. Okay, yeah. I'm going to go ahead and start writing it, but I'm telling you this because I'm going to do it differently than 3 of you did it. That doesn't mean you're wrong. You keep working, and then we're going to go through that way too, okay? Okay, once you get to one of these 2 steps, and just like on the other ones, one reason why consistency is good, it's a quadratic. Set it equal to 0 and factor, okay? And I think I did something wrong with the sign somewhere, didn't I? I did. I didn't make this negative. Dang it. So this would be negative and negative. Negative and then negative 30y squared. So your work could look like one of these 2 things depending on how you did it. But if I want to set it equal to 0, I think I'm going to put everything on the left-hand side. So in this case, I'd have 48y squared y equals 0. And if I did it this way, I'd have 16y squared plus 6y equals 0. Okay? And then factor out a GCF and solve it if you haven't done so already. So it's still equal to 0. Wait, hang on. What? Oh, you subtracted 18, so everything's negative. Okay, gotcha. Oh, yeah, that's totally fine. Okay. So then this gives you a 0, and then you can set that equal to 0 and solve that as well. Okay, so you get the same exact, so one reason why I wanted you to work this one on your own, because you could use 2 as your base or you could use 8 as your base. And it doesn't matter either way. It's whatever you figure out, as long as they both work, they both work. Your work looks different all the way up until even the very last step when you factor, but your solutions are the same in both. Okay, we good? All right, don't let the quadratic stump you, because I know y'all know how to factor and that's not going away. All right, let's look at what happens on something like number 11. All right, so I have common bases, but I got 2 of them on one side, right? And I can only have 1 5 on each side here. So I need to actually combine them. So when I combine these, I'm multiplying 2 things with the same bases. I want you to think about what you actually do with your exponents. If I have 5, let me use something different. Let me use x to the 4th times x to the 3rd. What does that become? You know this, it's not a trick question. X to the 7th, right? You add the exponents, you don't multiply them, right? You've known that for a long time. So that's what's happening up here. The 5s are basically your x's. You are multiplying 2 things with the same bases, so you add the exponents. So this becomes 5 to the c minus 1 plus 3c plus 2 power equals 5 to the 7c plus 16 power. Now I have just 1 5 on each side. Now I can use my 1-to-1 property to take it out of the exponent. When I take this exponent down, I'm going to go ahead and combine. So that gives me 4c plus 1 equals 7c plus 16. And then the rest is cake, right? This would end up with 3c over here and a negative 15. C is negative 5. Okay. Make sense? What to do with the exponents? All right. Then you do number 12. Beautiful. Put them in little set brackets and you're good to go. If it's a quadratic, what should we do? Set equal to 0 and then factor. Yes, set equal to 0. The pre-cal part of this, or the whole exponent thing, is doing this and getting to here, and then the rest is algebra. It's not pre-cal. You can factor it. Did you factor it? Factor it. Quit looking up there. Factor it. Don't wait on me to write it. Two numbers that multiply to give you 20, that subtract to give you -1. Yes. That's your answers. Okay, we good? All right, what questions y'all got? You can do this, right? All right, good deal.